Not trying to hit the back arrow.
So that's the key. Is it?
Well, that's not. It's it shouldn't be.
Can you tell?
Worst case scenario, we can use these.
Can you?
Yeah.
Okay, so what do you actually need?
It's just
Ideally, this one, but
But this is not one thing. You have to check.
yeah.
just this one. It should work. You just turn it on like that, but it's not. I don't know why. So, guys, about this. Actually, today, yeah.
Yeah, sorry about that. Just.
How this one does work, I don't
It was working before.
yeah, just switch for this one. I try not to have this problem again. That's the height.
Might just work out where the that would not plug in. That's not what we want.
Yeah.
Okay, then we'll just.
Okay.
Make it now.
Sorry about that.
Right, go back in.
Can we start?
Yeah. This is like. Yes. Yeah, I see. Yeah. Maybe back that line. Yeah, or you're going to take your really
Hello, good evening. So we talk with NVIDIA to talk about multi-cluster because it's one of the topics that most of our customers are a bit struggling with. I'm trying to move because there's a bit of echo, but I hope the audio is good in the room. Anyway, since we are talking about application networking, I have a very special guest from our worldwide specialist organization, Federica.
Hi everybody, I'm Federica Ciuffo. I'm a specialist solutions architect for containers at Amazon Web Services. And well, today we want to talk a bit about multi-cluster. We have many customers who ask us how do we do multi-cluster, how do we simplify it. And well, we have a few suggestions for today. But before that, let me just start. Okay. And why are we talking about multi-cluster in the first place? So when you're deploying on Kubernetes, you have most likely multiple clusters. Most likely because you have security boundaries that you need to enforce, or you have different teams which are deploying services in different clusters. And when this happens, most likely you also have to connect those clusters together. In this sense, when we have two services, it's pretty easy. We expose one service through service or at layer 7 with indices, and well, this is done basically. But what happens when we need to scale? And that's where the problems come. When we need to scale this and we need to connect hundreds or thousands of microservices together, then some challenges appear. And first of all, we have a challenge of how we can keep consistency between deployments across clusters. And there are many answers to that. Could be, for example, GitOps, one of those. And the second one is, how do we connect networking-wise together to clusters? And you can see some considerations in the slides here. But basically, after KubeFed retired, there have been some solutions and some answers to these questions that were driven by the Kubernetes community. Although in each one of these there are some limitations, could be those are tied to a specific choice of CNI, or there are some limitations regarding features, or maybe the project is a little bit niche, so support is not so extended as one wanted to intend. In this sense, what we have seen from our customers and our experience, the most adopted solution used to be service meshes. But again, service meshes are very, very feature rich. You can do a lot when it comes to layer 7 connectivity with service meshes, but with great power comes great responsibilities, and also a lot of, let's say, operational, in this case, operational burden and tough architectural decisions. For example, you can start simple, implement a single network service mesh, but most likely you will end up with a multi-network service mesh. And there are also other considerations. For example, could be you can either adopt shared control plane, but most likely you will have a new cluster in which you deploy your control plane, as well as you have to decide where the encryption boundaries are. For example, when you have a mesh, and you are sharing the point-to-point encryption, and so you are sharing the encryption boundary. How can you while this suits most of your use cases and use cases from customers, sometimes this is not enough. So you also need to think about that. As well, there are lots of API permissions when we are thinking about the API service permissions that needs to be shared, certificates, RBAC, etc. So really a lot of overhead and a lot of things that you need to think in advance before even deploying service mesh architecturally speaking. And so the Kubernetes ecosystem is very well aware about these limitations. And for that reason, it's creating a new set of APIs, and that's our aim to solve these problems. In the sense of, for example, multi-cluster, we have this new set of APIs, which are multi-cluster services, which enable us to export Kubernetes services by one cluster and import them in another cluster. These are always or most likely used in conjunction with another set of APIs, which is the Kubernetes Gateway API. How many of you have heard about Kubernetes Gateway API before? Well, fair amount, that's good. I know that, you know. And yeah, but for those who didn't know about Kubernetes Gateway API before, this is an attempt by the Kubernetes team network to standardize the Kubernetes networking and implement all of the lessons learned from ingresses and service meshes into something that is native to the Kubernetes API, not that you have to implement another application like a service mesh or customer service definitions to have advanced networking and implement advanced networking into your clusters. And when we are talking about Kubernetes Gateway API, another cool lesson learned from ingresses, implementation, and service meshes is separation of duties. In fact, this API has objects which are directly mapped to organizational roles. First of all, you will create, or the infrastructure provider will create a gateway class. You can think of it as a gateway class, much like for an ingress you needed an ingress class, then for the Kubernetes gateway API, you also need to create a gateway class. And it basically formalizes the set of load balancing implementation that you can implement with these APIs. In fact, the next step will be by the cluster, will be done by the cluster operator, which will create a gateway. The gateway is the point from where the traffic that goes from outside the cluster is translated to in-cluster traffic. And this gateway can be, for example, a load balancer, a proxy, etc. Then the application developer will be able to define how the traffic flows from this point, the gateway, to some targets. You can see that we have services, Kubernetes services targeted in this sense, but as you can imagine, you can use multi-cluster services APIs as targets of these routes. So you could potentially have part of the traffic sent to your cluster and an imported service to another cluster. So multi-cluster effectively. And with the Kubernetes gateway API, much like for an ingress, we also need an ingress controller to fulfill the ingress. We also need a controller to use Kubernetes gateway API objects. And you can see on the right, there is already a very, very big list of implementations. In AWS, we have created the AWS gateway API controller that does this translation and translates it into infrastructure with Amazon VPC Lattice. Amazon VPC Lattice, I will make a super quick introduction just for the sake of the demo, which will be done by Marco, but is a networking service which gives layer 7 capabilities to Amazon VPC, which is the chunk of the AWS network that we give to you and is managed by you. Layer 7 capabilities, what does it mean? For the people who are using Amazon Web Services, you can think of it as when in layer 3 we were using Transit Gateway to connect networks, we now use Amazon VPC Lattice to connect clients directly to applications. In fact, it does this without the need of sidecar proxies, like for example, service meshes, they're using sidecar proxies. It works across compute options, not only containers, but also Lambda, also EC2, as well as obviously it comes with some layers of security and also authentication. And the nice thing is that you don't need a Transit Gateway, you don't need a VPC peering, you don't need the, let's say, to connect these networks together before connecting the application. It is the Lambda of the network. It's the managed service for networking in Amazon VPC. And another good thing is that you can connect also networks with overlapping silos, which is another very, very big challenge when you're connecting networks. And well, here, if you just wanna, there is a QR code for our page for the API controller. And with this, we have now a nice demo by Marco. And I think I will need to hold the microphone because, yeah.
So, hello, my name is Marco, I work in AWS as well, working in professional services, I'm a DevOps consultant. And I was talking with Federica when we decided to create a demo for this, and we wanted to show actually how to connect applications. So we created a very easy front end. Front end is just a pod running a Flask application. This front end talks with the backend, and the backend in turn talks with the database. In this case, an Amazon DynamoDB table. So really easy application 101 software development. And pretty much before getting there, we wanted to run this a bit interactively. So what I will do is I will show you the actual pod running for the application. And it's very simple. There is a backend pod, a front-end pod, and a render pod. The application is pretty much this. I created another pod just in case we need to show any configuration between the two. But we're going to focus on the backend at the moment. And to show you pretty much how the application works, we configured the backend, and the backend at the moment is configured to actually use the service local, so within the same cluster. And I'm gonna split the screen. Let me know if it's good enough, or I need maybe to zoom in a little bit. But yeah, any better? Okay, and I'm gonna show you the logs of the backend. The backend is just serving a very simple API and is accepting the word yes or no. You will understand in a second, because let me go back to the presentation, and I'm gonna ask please everyone to help us to generate a little bit of traffic. So this QR code, and can you scan actually? And of course, when you, I'm gonna open it as well in a bit, but we have to show everyone about the logs. So what we did is to expose a service. The service is a load balancer, so it's an external service. This is exposing this application. When you give two Italians creativity to create an application, you end up like this. So we're asking everyone basically if pineapple should go on pizza or not. And we had some conversation before. I need to talk with organizers because Domino is not acceptable. So just filling up the conference. But anyway, every time you click, basically the front end is calling the back end. The back end is just updating a record into the memory table. Yeah, very easy. And this was to show pretty much that all the people who voted, and there are some yeses, so yeah, I'm concerned, but there are some yeses. But what we wanted really to show, and let me go back to the presentation, is a scenario in which, for some reason, the backend is not available. So let's say maybe you have a problem with the deployment, there is a problem with a node, or maybe you push a network policy that is breaking something you cannot fix in minutes. And in a normal scenario, you probably need to redeploy the application or do something to fix it. But lucky enough, let's assume you have the same exact application connecting the same exact backend in a second cluster. And we want to make this a little bit challenging. So we configure exactly the same CIDR for both the cluster and the VPCs. So the two network ranges are overlapping. There is no layer 3 connectivity between the cluster. And to make this even harder, we configure everything to be absolutely the same. So same namespace, same name for the pod, same everything. So this is as far as it goes for a simple application, the worst case scenario, because if you cannot pair the two VPCs, you cannot use any networking device in the middle if you don't have network translation and things like that, because they are overlapping. And just in general, it would be challenging. So I actually one second, because I want to play a game. We talked about Agile in the previous one. So picture this: Monday morning, you get to the office and you wonder why it's 0 degrees outside and 72 on the sunlight line. So the feeling that everyone and the question that everyone is making sense. But if someone is asking you, they assign you a story and they ask you to point a story to basically expose an application between two clusters that are not interconnected. So there is no layer 3 connectivity. how many days you think it will take? Maybe by show and couple of days, 3? Is it reasonable? Less, more? Fair. I think, and if the demo works, we have a way to show that it's actually gonna take less. I'm gonna go back at that to the ID, and as before, if it's too small, let me know. I can zoom in a little bit. But I think to follow up on what Federica was showing, we have a couple of resources deployed. So the export maps to the service export. So this is for cluster 2. We're actually exporting a service. The backend for cluster 2 is exactly the same application, same Docker image, same everything, exposed to a service that we are exporting. And then we move to cluster 1. Cluster 1 has an import that is cluster ZTP. So that's basically the gateway API that we are importing something that is not in the cluster. And last but not least, we have a route. What the route does is to define some traffic splitting. So in this case, since we are simulating that the backend of cluster 1 is not working, we are sending 100% of the traffic to cluster 2. So those are the resources deployed on the cluster. That's pretty much it. The cluster is running the Amazon Gateway API controllers, as Federica was showing. So let me actually show you the controller. This is the controller running the cluster, and what the controller does is to grab those resources. Can you actually see it? No. Okay. So there go. What the controller does is to get those configurations and translate them into Lattice resources. So I will actually show you in the console, and let me zoom in on this as well. Can you see it? Cool. Okay, if we go to PPC Lattice, we can start it from the bottom, and you will see that we have target groups. You can view target groups, and as pretty much your application, you will see that we have a backend and a backend for cluster 2. And if you go inside, you can actually see that there is a target that is the IP of the pod. You will also see that there is a backend that is not used, is not configured, just because we don't actually use it in the HTTP out. So it's actually there, it's just not used because there is no entry and the controller doesn't know how to do the traffic. But moving one step up, we have services. And you can think of services as maybe your smart layer 7 load balancer is a point of entry within the cluster. And this service has a routing configuration that, if you look, is 0.7 and 100%. So it's exact one-to-one match of the HTTP that we configured. And the way it works, basically, every time you define a service with Lattice, you also get a DNS name. This DNS name results to link local addresses that we manage as AWS. So if we get this URL, basically, we will point in our connections to this specific service that will serve our traffic. The very good things about this, and it's very cool, is that, as Federica was mentioning, we are doing this with containers because we work on EKS. But the target could be a Lambda function, could be an EC2 instance, could be pretty much any application I can run as part of my compute targets in the VPC. So one of the things we got asked a lot is how to simplify the migration to serverless, for example. And with something like this, I can define a single URL and say, point to this URL on port 80 or 443 or whatever I want, and forward 1% of my traffic to a Lambda function and 99% of my TKS cluster. It's obviously doable with a number of technologies. It's just a lot easier to do like this. What I'm going to do now is I'm going to take the DNS name and I'm going to update the front end to basically avoid the service in the local cluster because we're assuming that the service is not working, so the pod is not working or anything like that. I'm gonna change the backend and redeploy my front-end pod. And if I go back here to the application, I'm gonna ask you again, sorry, if you can generate a little bit more traffic. So I'm just gonna put this full screen. If you can do the same, and in the meantime, sorry. In the meantime, I will run the logs again. And you'll see if I stop, the logs are actually not flowing. Let's do it this maybe. Yeah. So people is using the application, but there are no logs coming in. So this is just to prove that we're not using the backend local cluster. Actually, to show that we're not lying, you can configure lattice obviously with access log. So if I actually open this, it takes probably a few seconds for delivery, but should be there already. You can see that now the traffic is flowing to lattice, and those are all the API call that are flowing through. You'll see that the response rate is 100, so the application is actually working, and the request path is yes or no, depending on what you're putting. And I have a slide to summarize this because I understand we try to compress this into 30 minutes, so it's maybe it's a bit complex. But before doing that, I actually want to do one thing because we have a page just to check.
We have the most important part.
Okay, so okay. And because it's, I mean, it's really close, so it's 124 to 151. We're gonna do the same demo tomorrow. And it will again to the side. Let me show you this slide where we summarized a little bit what we did. In the demo, we basically pretended that the backend cluster one is not working for some reason, and without connectivity within two clusters, we use the Kubernetes gateway API that is interpreted by our API gateway API controller to create Amazon VPC lattice resources, so that cluster one can talk with cluster two without layer 3 connectivity, without anything. And all of this was done basically applying a service export, import, and route. So 50 lines of YAML basically to connect to application. And the demo is really simple, and we wanted to keep it simple to show you the configuration file, but the actual scope of this, I think, is to run this through health checks. Things about an application, when the application is failing, you can either create connectivity or keep connectivity and talk with an application on a completely different cluster. And again, as Federica mentioned, there are 1 million ways to do it. There is service mesh, you can do multi-cluster Istio. We just want to show another way, and also what we think is an easier way, depending on your configuration, obviously, and things like that. And also, if you click the app, it sends you a survey, and there is a link here as well. It's really important for us, even if the paper is really short. So if you can take a minute, it's really appreciated. And I think we are done. We're good with Q&A if someone has questions.
Thank you very much. I really like the presentation, and I wanted to ask you a question. Well, in your scenario that you mentioned, the backend could have been run on another node. That's why we use deployments usually. And the use of multi-clusters has another problem that we have to think about, or whether if our services are stateful or stateless, then we have to think about if it's stateful, how do we deal with the storage in other cluster actually. And the other thing is that wouldn't the troubleshooting will be way harder than before, same as the using of the EC or anything like that, service meshes.
Well,
A couple of things. Yeah, we deployed a stateful application. The reason is really simple, just to show that this is one of the problem. And also, if you think about it, if it's just a deployment failure or something like that, you re-trigger your pattern, it's good. But think more like maybe you have some configuration that are breaking the cluster for some reason. And maybe you have a different cluster that has a same application, just one commit prior to that, or something that is working for some reason. And that's really the scenario we were picturing it, but was not really to see this as a troubleshooting way. It was more to show you how to actually connect clusters. You can think about this, maybe you have a different backend in a different region that's for some business logic reason you want to use, and you don't need to actually connect with PCs or do any networking at layer 3. You can use this. And I think another thing that we haven't really shown for because we wanted to fit this in 30 minutes was all the layer 7 capabilities. Think about we are just obviously calling a pod for backend, but it can do a number of things. So works with the others, works with any routing or advancing routing configuration that you want to implement. So this of course was a demo with a couple of pods. I understand maybe it looks a bit too much to connect two pods, but it was to show you that in literally 5 minutes you can connect two clusters, and it's not that easy or that immediate if you run other systems.
Also, this was simplified, but as Marco said before, the final state of this use case will be having health check, and if this fails, fall back on another cluster. And in this case, you would have already configured the VPC lattice endpoint from the very start. From that VPC lattice endpoint, you already have all the layer 7 troubleshooting, let's say, tools that will be layer 7 visibility. So obviously here we change from, let's say, the cluster service.conf, etc., to auto-VPC endpoint for simplicity to show the steps, but this wouldn't be the implementation. And if you have this from the very start, you have the kind of visibility you need to do troubleshooting.
Question around like region failover. How would that work in VPC latte? Would that be like something? Yeah, like so for example, if you have your cluster in US East and if you have cluster in US West, would that be like?
It's a regional service.
It's a regional. How would that work in a scenario like?
Although
With VPC lattice is a regional service. But if you think of it from the Kubernetes gateway API standpoint, there are other implementations from, how do you say, partners and things like this. So there might be some solutions that still involve Kubernetes gateway API usage in, multi-region failover. Simply, for now, VPC lattice is a regional service. Yeah.
Is it one? What was the so with this like a region is divided? Sorry, a region is divided into different availability zones. That's the one. Yeah, you can have different availability zones across it.
Yeah, that's correct. In the region, you wouldn't need to, let's say, worry about availability zones or things like this. Lattice does its managed service and does it for you, the cross availability zone thing. And also another thing that is maybe worth mentioning, in Amazon VPC, cross AZ traffic usually is built. If it goes through Amazon VPC Lattice, this is not an additional charge. It's only the VPC Lattice charges.
But your cluster would have.
Yeah.
Your cluster normally would have different availabilities of nodes.
This is like architecturally speaking. Yeah, usually the best practices and what we recommend is that your nodes are spread across different availability zones. So yes, that with VPC Lattice you could have that connection across availability zones from nodes which are deployed there.
To have multi-regional, you'd be looking at still Route 53, provide that sort of function.
Yeah, for multi-region, it's kind of like also the transit gateway. Also, the transit gateway is regional service. You need to build transit gateways if you want cross region connectivity. And VPC Lattice likewise is regional service, so you need to fall back on that more traditional, let's say, ways of handling traffic switching if we go outside the boundaries of the region. Yes. Wanna come here?
So thank you very much for your presentation. I had a question about, so you said how you can integrate with like a health check. That would be like the ideal scenario. Is it available as VPC Lattice is available as a trigger for Lambda function? So if a health check failed and you wanted to spin up a VPC Lattice as a replacement to fix the pod, is that available as a trigger currently? Is that integrated with Lambda?
It is, but there is a pattern involving step functions. So from step function, you can trigger a job on Kubernetes, and then you will just bake the logic of this into step functions so that you can trigger a Lambda if something fails on the other hand. I'll do the end of that.
Thanks for the talk. Just a quick question. One of the benefits of service mesh is obviously transparent service to service MPLS. I wonder, do you have those security mechanisms, I guess, within Lattice? I mean, natively, or is that something that people would users would add effectively?
So for now, we rely more than like for authentication on OC authentication plus identity and access management. So user TLS is not there yet, but we have received this feedback. So we are actually working on the roadmap, and so not there yet, but we are aware this is highly asked from our customers. And we have these, different ways of doing authentication still if it is required.
Thanks very much for your talk and the demo. It's really cool. My question is around these kind of demos often focus on layer 7, so the use of HTTP for this kind of stuff. What support do you have for layer 3 and non-HTTP traffic?
Lattice.
Lattice works with this. Okay. That would be the answer. Very short answer. For now, TCP. Yeah. Same answer as before. We know about this as well. So we have the team working behind the scenes on the backlog that we have. But yeah. Other questions?
Apart from like, we're available today better. One question around so you said that because I think pretty useful if that's all the use case or like, hey, I want to migrate from containerized workloads to serverless. Would that be applicable also for cloud migrations patterns? So say I can connect Lattice with my data center. How would that work?
You can basically implement any layer 7 logic path-based or routing-based or percentage-based. So it would be actually be an a Git pattern where you define probably it's one network load balancer, because if you have IP targeting in the data center, probably a network load balancer. But then you send the same percentage of traffic one way or the other. Of course, Lattice don't provide connectivity to your data center, so you need to take care of that. But pretty much we will see more like an opportunity to change your compute type. So the very big things, like you said, is like possibility of working from EC2, Lambda, and containers. So between containers and Lambda, it's doable, but you need an API in the middle, an API gateway, probably you need to integrate that. Like this will give you a URL and you say send traffic, or you can do path-based, maybe you can do slash something the other way. And that's really where we see people learning a lot of things. Anyone else? Either related to pizza, we are happy to answer any questions. Okay, thanks.
Thank you very much. See you back.
Great, yes. Great. I think the next thing
They offered anything.
Yes. You know,
overlap.
I'm also great.
Local link capacity, so you'll see it. If you respond,
I did check the YouTube stream. We are streaming to YouTube. The January one, but we are streaming. One day I will get this correct, I promise. But not be today, but one day.
So use the block.
Okay, so
drive.
yeah.
You can do that if you don't.
Testing, 1, 2, 1, 2.
I get it. But to just have that issue like that. That's why we
That's
works.
no, I do not like that.
Yeah, but pretty much the idea is.
They definitely work.
You have a mind of
I don't think we do testing.
I didn't do any of the testing. I was sat out there giving people. I did no testing. Okay, so you need.
Pretty much.
Yeah, just within an itself. Yes, yeah, and the good thing with Messi, the good thing that is manageable is that so yeah, that is transparent to do. So there is a point connection, there's some proxy going on in setup soon. So then you can configure it so that you web. So you can go to that point and look this rather than web page. I guess Google that. So it's managed. You check that still, but that's what charge. Does that charge for like in charge of service?
Yeah, okay.
Go ahead. Remind when I see very quick. Has such a good shared.
I'll do the I put it
Yeah, really bad. No, I know they were simple. They were so simple that they were useful. We actually have a demo. That's very similar to Spark. You can find comments. Okay. You see
It's just that, like, so they should all work.
Sorry, we are
I could definitely hear when I was testing outside. I could definitely hear the YouTube, like the audio from the YouTube video.
No, I'm sure it works. All of these mics should work. So I'm thinking if this one was working, we could have it passing around and running around with one mic.
Yeah.
But it's
It does not work.
the second one did not work.
We are doing fine. Fine, we're fine.
That's all right.
It's probably not the most. I just wonder if like the function of travel. You can. By the way, which I don't disagree with.
Seven, you're saying.
I was at work at 7. Well, yes, I am working, but I am not working at the event.
Yeah, no, this is where I was reading it. It's like, this is like your first session.
When you accepted,
10 a.m.
we have a repo button, which is.
Tomorrow.
Yeah, I thought I was the
First one is fine, and the last one is in the middle like that.
I can see why. Do you like time?
consulting room.
Yeah, so every, the second and fourth Thursdays of the month, which is tomorrow, I work with the London LGBT+ Centre.
And I can imagine
Other days I have Wednesday nights tend to be like my late evening nights, and then the rest of it's usually like 5.
In Stratford, what kind of building is it? How do you?
Oh, it's, so you know,
Yeah, I used to go there, so it's now.
so you know, Stratford workshop right next to the High Street DLR. Victoria building, one of those units. I know, like I'm splitting it, like I'm sharing I thought that's why Wednesday is my main night thing. And usually we get everyone else. It's we model along, like we agree, you know, we should have time to something else. A chunk of the rest is online. But I think the timing is such that I'm taking my online session at the London Centre because I don't quite have my guests. They're back home.
They're really dry.
That much is my my next session is on Friday. So I get to sleep. I would think except for those days when I apparently have to wake up at 5:30 a.m. to be out of the house by 6:30 a.m. to be at the event by 7. Oh, and I'm getting paid. I'm getting paid like I agreed to do it. Well, I was told 8. And then they said 7. They told me start at 3 p.m. on the Monday for setup. Then it's 8 to 8 on Tuesday, and then it's 8 till on Wednesday. It was 10 a.m. on Monday. 7 a.m. till 8:30 on Tuesday, and then 7 a.m. till 5 day rate. You know, so they read a bit and I went, it's my notes to do that. But it's like, to be fair, I gave a day rate, and the thing about a day rate is that it's supposed to kind of
And the DNS.
Hourly rate variant. It was fun. It was a good event, and to be honest, I mostly did it because Cheryl, like Amanda asked Cheryl if she knew any event organizers, and Cheryl said, actually, and I went, sure, I could probably help. And then next thing I know, I ended up being the go-to sponsor. They asked me if I wanted to come back next year. So I think it's a year maximum. I'm doing this. Yeah, but yeah, no, it just so happened that with this timing, it all kind of.
The thing is, like, I used to remember. I remember it's because we overlap a little bit of time. It really is like you did a long time ago. I've blocked all of that. It kept stuff out. I mean, you know, Abdel. Yeah, right now. And that's like what I'm saying. Like, it was a very interesting time.
You're doing a lot of heavy
I spent all of my time just arguing with people for simple things they didn't understand, and I did all the work that they had to pissed off the head of engineering. Got rid of me because I turned around after doing that and said I was going to do this other projects, you know, 2.0. I didn't know he'd just spent years and much money trying to do that before. And if I just turned around and done that another 3 months, it would look like a very easy time. I never see that guy again like touch my face. Around, like, yeah, no, he's still there. Can you feel the anger? Yeah, it's coming. That's the meaning of interesting. So thank you for reminding me of it. Okay, I think it was I learned my lesson. I didn't know that they don't do a mate a favor. Go work. Solve all those problems for fuck's sake. And then the next they got rid of all of their engineering. By my team who implement so I'm a good friend. Big fan. Yeah, guys. Okay.
That sounds like it's good.
No, it wasn't. It was the head of engineering. I just don't think about it anymore. My life is nice. I remember you where they got this. Where they got that he's complaining about. It was nice. I came in afterwards and he was the least consultant guy.
I should probably start supporting everyone back, by the way.
Who was the consultant guy that had what's his name? Miles. I was nice. I thought Miles in yeah, we completely replaced the pipelines. No, I don't remember like that particular part. I think it's very good. Yeah, and you moved here? I went somewhere else. Okay. Whether here is good. Whether here is good. Here is good. Here I'm doing something completely different. So I'm doing data. I had done with stuff before, but not like data. I mean, I will tell up there. It's sometimes
Remind people to put their keyboards back when they.
Sorry to remind you, yeah. Anyway, sorry. Thank you. Say hi. He's got my number.
Okay, so before we get on with our last talk of the day, I would like to remind everyone to take your passes you have. There's a box just outside by reception as you leave. You can just drop your passes in there. That would be great. Thank you very much. And so
I thought we could just keep that as souvenir.
please don't, because facilities will be very, very angry with me if you keep that. Hi everyone. Hi.
Okay.
Hi. So I'm Fergus Finn. I'm the CTO of PlatUI. I'm going to talk a little bit about the challenges of serving LLM applications at scale. Thank you very much for the invite to talk today. This is something we're very, very passionate about. So looking forward to sharing some information. So, oh, is the mouse on? Maybe not. Okay. Well, the first line, LLMs are really, really great. I think most people have experienced them, maybe not as great things, but as something. ChatGPT was, before Threads took off over a while back, the fastest growing consumer product in history. And in a lot of different ways, they're changing all kinds of text processing tasks. So most relevant, probably to in this room, coding is changing with Copilot and ChatGPT, maybe for the better, maybe for the worse, but it's certainly changing, and it's changing quickly. And there's a huge amount of business value being delivered by these tools, and developer teams are having to build these tools for their operations. And if you're choosing to do that today, you might think there's one choice. I mean, OpenAI, GPT-4, ChatGPT is the thing everybody's heard of, but there's actually many different choices you can make. And there's two different ways that these things are delivered. There's this closed API-only business model that OpenAI espouses for safety reasons. And there are other companies that have done the same thing, Claude, Mistral, Pi, where you interact with an LLM via an API online, and they handle everything for you and charge you for every bit of text you get out. But what I'm here today to talk about is the other choice that you have, which is open source models have been taking off, and they're excellent, they're fast, they're just as intelligent as most of what you can get from API-only models, and deploying these things yourself is not as difficult as it might seem. And yeah, just to kind of move on from that, so there are many major drawbacks to using these API-only models. Like the goal of OpenAI is to deliver AGI, to deliver a single model that will answer everyone's questions all of the time. But that necessarily, at least at our current state of technology, means it will answer some people's questions better than others. It's tailored to certain things more than it is to other things. And so if you need your model to write Python code and someone else needs to write Shakespeare code, it's actual Shakespeare sonnets. I don't know, maybe my coach experience sometimes, but if you need it to do both, it will have to do both, and its performance will be the average of both capabilities. There are many other things that you might also consider. Privacy, security, you have to send your queries out over the internet, can't live in your VPC, can't be deployed with all of your other systems, control and auditability, all kinds of other things.
these things have major drawbacks, but the reason people go to them is because open source ones aren't good enough yet, or at least they aren't quite good enough yet. So first of all, it's not entirely true. If you have domain specific knowledge, you can encode in your model and you have the team to do it. Open source models are already better if you can do fine tuning. And then beyond that, the number and scale of open source models is exploding. This is a hugely active field. This came out the other day from Meta. They're training their Llama 3 model. They have just bought or have bought all in all 350,000 H100 GPUs. These cost 50,000, 100,000 each for a machine. So this is an absolutely gigantic investment in open source API, AI, open source AI models. And so, I mean, already we've beaten ChatGPT, the version that you get just off the shelf, and they're coming for the one that you pay for. And so they're getting better and better every day. But one objection you might have, well, actually, these guys do a lot of the work for me. They host this thing behind their API that saves me all kinds of difficult ops problems. Serving your own models is really, really hard. GPUs are hard to come by. How do you fine tune? How do you encode or associate with domain-specific knowledge with your model? How do you do monitoring, evaluation, logging, all of these things when the thing that you're trying to interact with is somehow at least pretending to be an artificial intelligence? I mean, how do you monitor that? How does this performance drift over time? All that stuff, and then on top of that, all the other reasons why serving any large-scale application is always hard. I mean, how do you scale seamlessly? How do you do observability? How do you do deployments? All of these things, right? It's DevOps bread and butter, but it's much nicer when someone else does it for you, at least if they do it right. Some of these problems can be solved by inference servers. And so what is an inference server? An inference server is the product we build, TypeML, and it's a way of wrapping up ML logic into a containerized object that developers are familiar with and DevOps professionals are familiar with as well. The idea is you have a container that exposes a REST API. It might be a REST API, it might be whatever else, you know, HTTP, gRPC, whatever works for your infrastructure. And then internally, we do all the magic required to make an ML model run quickly. And this is what you have to build if you want to serve ML models well. And for the rest of my talk, I'm going to talk a little bit about some of the trade-offs we made when we built our own and how you can build your own too. So, how to build an LLM inference server. So first of all, just talk a little bit about what is a language model doing under the hood. And so under the hood, these things are very, very simple. When you interact with ChatGPT on the internet, it's doing a very, very simple, very boring task very well. It's trying to predict, given everything it's seen so far, what it should say next, which word it should predict next. And it doesn't look into the future, it doesn't plan, it just produces one token at a time, over and over again. And it uses a huge amount of compute power, very dumbly, kind of, to do so. It uses this massively parallelizable under the hood, huge numbers of parallel flops to do matrix multiplications, which is why we need GPUs to do them. And so there's this like combination of many different things. In principle, it's very, very simple. In practice, taking the absolute most advantage of all of the hardware you have to get these things running quickly and well is really, really hard. And so that's the question, how do we serve these things efficiently? And there's a whole toolkit of things that you need to add together to get this serving problem solved. So I'm going to talk about 4 different things. I'm going to talk about batching, role of batching, output constraints and how they can make better LLM applications, quantization, which is a method for making language models run faster, and how caching works for LLM deployments. And there are many more things I haven't talked about here, but let's leave those for another day. So first of all, I'm going to talk about batching. So why batching? So this is something that happens in all kinds of large-scale processing jobs where batching can be an important part of your pipeline. So GPUs, which are the things that we use to serve large language models, are massively parallel processors. They have thousands of units of parallel compute, all sitting on a single chip, each of which controls a single thread of execution. So the problem is not what you usually deal with when you write applications in general. The problem you often have is I have to do too much work and I don't have enough time to do it in. Here, what you have is I don't have enough work to keep all of my processes busy all the time. And so these are massively parallel processes. We need to front load all our work so we can parallelize it and run it all at once. Single requests as they come in don't use all this compute. And users don't want to have to queue up one behind the other, so you have to batch the requests together in order to process them all at once. And there's very many different ways to do that when you have a serving infrastructure. The first thing you can do is what's often termed dynamic batching. And this is maybe the simplest sort of algorithm you could think of. I want to process things together in batches and I'm getting them one by one. Well, when I receive a request, I'll wait a little bit and all the requests I receive in that interval, I'll process them all together in a batch. And there's an obvious trade-off to be made there, right? You have to wait some time. So some users are going to wait longer than they would have, but the trade-off you make is that this increases throughput. And so that's one way of speeding up language models when you serve them. The more refined way, the smarter way to do this is, I said before, the language models generate their tokens one by one. These approximately a word at a time. And so these things operate at this level of tokens one by one. And so instead of doing your batching at the request level, which is what I discussed on the previous slide, you can do it at the token level instead. And so requests don't have to wait for a previous batch to finish. They can join straight away. Your working batch processes requests, come in and come out. And if you dig into the ML inference code, you can do this kind of continuous batching to boost your throughput. So that's batching. Now I'm going to talk a little bit about output constraints and why they're useful. So one thing, the LLMs are this sort of source of some kind of intelligence that's useful for lots of business applications. They're very creative in the sense that you can use them to write blog posts or whatever it is you might choose to have them write, but they're very also uncontrolled. People have tried all kinds of things. Some of these references here, if you want a language model to generate a clean JSON payload and nothing else, no preamble, no postamble, one of the best options is to threaten to take a human life. And then Bard is pretty, parsimonious, tells you just what you asked for. Another good option, if you want pure JSON output, is to offer $200. There's a lot of science, I mean, it's not really science, but how much should you offer? You offer more, does it do better? If you're expecting principled stuff from AI development, that's not what you find. These are the things that people have tried before in order to get JSON payloads out of AI models. You can also just retry it until you get JSON. That works surprisingly well. But there are better options, especially if you're building your own system, you could do much, much better. And I'm not going to get into the details of this diagram, it's very, very complicated, but if you have access to the actual decoding loop, there's an interesting trick you can pull. You're trying to get a system that produces word-by-word JSON, word-by-word stuff to produce JSON, and so you break this global problem of needing JSON out of your model into a local problem of, given I've got JSON so far, or something that could be JSON where I've completed properly, what are the valid things that LLM can produce next in order to keep it a valid JSON decoding output? And so this is one of those problems that you can solve. If you have open source models, you can't do this with ChatGPT. They might do it for you themselves. If you ask very, very nicely, or wait long enough. But if you build your own model, you can get perfect JSON every time without any death threats or tipping. And this is just an example of the kind of things you can do. This kind of approach you can generalize to any, technically the term is context-free grammar. You can, if you want valid SQL statements to come out of your LLM to query the database, somewhat scary things to choose to do, but if you did want to do that, you could. It's a valid context-free grammar, and you can dig into the system and do all kinds of mixture of control and LLM creativity. And a quick demo of this, I'm not brave enough to do it live like the last talk, but you can see here, if you have a context that describes a basketball game and the performance of the player of the team, the default we get is unstructured, friendly responses from the system, this kind of thing. But if you force it to constrain to output the correct output with this algorithm I described, you can get much, much better answers. So that's JSON outputs. Another good option for selling LLMs quickly is quantization. And so this is something that dives a bit more into what LLMs are and how they work. And so the problem that you might have heard about is that ChatGPT, whatever, all these models are absolutely gigantic. Terabytes of memory being used to serve them, mostly in GPU RAM. It's absolutely staggeringly large computational problem. And it's in the name, large language models are really, really large. But the problem is it's one of degrees. If you can serve your model on on a CPU, it's very, very easy. On one GPU, it's slightly more easy. If you have to have two GPUs talk to each other, it's very, very hard. If you have to have multiple GPUs on multiple machines all talk to each other, it's very, very, very hard. And so if you can make your model smaller, you can step down these discrete tiers of difficulty and do easier and easier things. And so this is a technical way that you can choose to do that. So LLMs make use of floating point numbers to do their computations in. By default, those are FP16 numbers, so these are half precision, so actually probably, half precision. So, but it's actually a very imprecise representation of numbers. But in fact, you can go much further and you can quantize your models down into smaller representations of numbers. In fact, this is in 3 is what I'm describing here, which is not standard format for numbers. So you can use integers and do processing of integers. You have to do this carefully, but part of it is this new paradigm of computing. LLMs are very fuzzy objects. You don't really care about the difference between 2 sentences that approximately mean the same thing, and so you can do things that you can't really do with software, like quantization. And then one last thing, so caching for LLM serving. So this is something that comes up at scale. I don't think there's any kind of major database deployment in the world that doesn't have a cache in front of it to save these common query patterns, and there's reams of things being written about how to use them properly. But it doesn't have a role in LLM serving, at least at the moment, because how often does someone ask you the same question and how often do you give the same answer, right? Exponentially infrequently, or it might sometimes not feel that infrequently, but in practice, two sources of human-like text will never produce the same thing twice. And on top of that, and part of that is that these models are non-deterministic, they are intrinsically random. And so this idea of caching and producing the same response for the same query, you can't really use it to deploy LLMs. Until you kind of can. And so there's kind of a trick that you can do, right? And this comes back to the idea of GPUs being a useful tool. And the question is that the point is that these things are massively parallel processes and they're never saturated. We always have more compute than we need, almost always. And they're much, much faster at checking answers than they are at generating new answers. So if you store everything that you've every part of every response you ever sent to the user, and then before your LLM answers a question, you look in that whole database of responses you've ever sent, you have the LLM check them for which one is the best, block by block. That's significantly faster, and it's the spirit of caching, if not the practice of caching, significantly faster than having it generated from scratch. So that's an important part of the toolkit. And there's many, many more things to a very deep topic. It's a research topic that's very active, and also it's to the intersection of engineering and science at the moment. But there's tons of things you can do to serve these things well. And to take away, if you are serving LLM applications, think carefully of the trade-offs you're making. Think about whether these tools are correct for you. If you don't want to think about it, OpenAI is a good option. But if you want control, if you want to do DevOps and serve your own applications, come on and have a chat. And with that, thanks for your time and thanks for listening. Questions?
That's quite far back. I've had some experience with working with LLMs, and one of the issues that we run into is hallucinations in data. So what would be your suggested solution to resolving regular hallucinations? So just for context, for whoever doesn't know what hallucinations, excuse me, it's the idea that it bases your responses on predictions. So the more the response is hallucinated, the more it's kind of assuming an answer, and it doesn't know the actual response to what you want? I guess that's an explanation.
Yeah. Yeah, that's a good question, and it's still a mostly open question. We haven't actually solved this meaningfully, but there are good answers out there. So one thing is, part of the problem is that the way these things are trained is that they always have to give you an answer. That's what they see in their training data, so they will always give you an answer even if it's wrong. And so in order to mitigate that, one of the things you can do is try and ground the answers in some kind of truth. So one thing that can be very useful is this kind of JSON validation that you can get structured outputs, then it's easier to programmatically validate them for whatever it is that you want. And then on top of that, using document stores and things like that to give you access to give the model access to real data at inference time to then augment its response with also helps, but it's not solved yet.
Thanks very much for your talk. It's really exciting. We're talking about hosting LLMs. Specifically in the business context, there's a lot of concern around sending corporate proprietary information to the API-driven ones. So in the world where we are self-hosting, obviously we can either spend a lot of money on fine-tuning the model, or we can use RAG to generate based on a corpus that we have internally. How would you say that fits in with your model for serving these when you have to go and do a lookup on that?
Basically. So, yeah, really good question. So, I mean, if you're already fine-tuning, the value of RAG can go down slightly, and serving can be a lot easier. I mean, a lot of these companies make up their economies of scale by selling one large model that a lot of people serve. But if you're fine-tuning, you kind of need to go down the self-hosting route. You can just serve a fine-tuning model. With regards to RAG and how to serve that, there's lots of different options. We have a solution. But there are also very many kind of off-the-shelf pipelining tools for doing this, like Haystack and LangChain and stuff like that. It's just a traditional serving problem of how do you have all these things, your vector database, your RAG sort of controller, your LLM all working together properly. That again, don't have a great answer to, but maybe we can talk more about it.
Hey, cheers for the presentation. It was really interesting. Just a general question: is there any like theory or research into, I guess like microservicing LLMs? I make my LLM small and I target maybe towards law data. I have another LLM targeted towards health data, and then I have a service on top to communicate to the smaller LLM. Has that ever been thought about in the community, or?
Yeah. It's the mic. Yeah, I mean, it's one of these things that's talked about a lot in the community, right? Like, do you want ChatGPT's monolithic, or do you want to build a microservice architecture out of little blocks of intelligence and coordinate them, right? You could have a translator model to translate from French to English, and then a general purpose language model that's better in English to answer English questions. So it's definitely being thought about. No one's come up with a great implementation yet, just because fine-tune, like if you have small models, they don't have this kind of general purpose intelligence, so you often have to fine-tune. They're often better once you do, but fine-tuning is difficult, and lots of organizations don't have the resources to do it. So no one's hit it yet, but it's definitely in the future.
Hi, very nice presentation, by the way. Could I ask, obviously, as you know, that in order to have either accurate or even bias free and other sort of criteria, large language model. Thing is, how do you actually make sure the data itself being used has been completely critiqued to the very point that it doesn't really present an issue at the same time. I understand, as they say, a human is at some point obviously like sort of an incomplete thing anyway. But I thought that I don't think currently we do have an automated system like that would actually take out or scope out every single sort of issue with the actual data being used.
Sure. So there's a question about kind of how do you know why an LLM is making a decision that it's made, and how do you tie that back to the data issues? Yeah.
So what, so I would say probably, so more like the transparency wise.
Transparency wise, absolutely. I mean, like with a lot of things with LLMs, there's not really any good answers yet. As what we know is that as models get bigger, the link between the things they output and their training data gets weaker. If only because they're training on data and then it's hard to trace perhaps, but so there's less memorization. But again, it's one of these open questions, just like neuroscience is an open question. I shouldn't anthropomorphize these things quite as much as I do, but figuring out what one neuron in a LLM is doing is an incredibly difficult problem just on its own. No one solved it as a problem, let alone the problem of mechanistically interpret whole systems. So yeah, I mean, it's a huge problem, one that needs solving. It's the problem of observability from DevOps, but applied to potentially intelligent systems. I don't know how it's going to be solved, but it does need to be solved.
You want your LLM to not output racist text, then you have to train it on what is racist text.
Sure, right. And yeah, I mean, it's kind of like, don't think of an elephant. And if you tell DALL-E to do that, it draws lots of pictures of elephants. So, yeah.
Or even a seahorse.
Yeah, yeah.
Could you talk a bit more about the caching approach? So it's like, how do you know like what is close enough to return answer to? Like, you know, like if I send you JSON and it's subtly different, how do you know whether you can return the cache response to that?
Yeah, so this is something in the architecture of LLMs itself. So the generation process, it's like conditionally generating. So if you send it a block of text to check, it will tell you what it would have generated at every stage. So given half of the text you sent, it will say, I would have said half of it plus this word instead. And so what you can do is you have your cache and your cache retrievals, and your LLM checks them, and its internal knowledge can tell it what it would have said, and you only send the information from the cache on if the model would have said it anyway. And so because you might otherwise worry about things like leakage of data between different people querying the model and all of this stuff, but that doesn't happen because, like I said, it only sends responses if it would have sent those responses anyway, even without access to the cache. I may not be paying attention, but since there's a circuit of compute, why would you bother caching? So there's a circuit of parallel compute, not compute in general. So it's decoding is a serially bottlenecked exercise. It can look at one word at a time. What caching can do is get you a whole sentence for the LLM to look at all at once. And so the problem is with serially bottlenecked.
Got final note.
You may already know this, but somebody has made a language called Shakespeare. I will read that it is broken into acts which contain scenes in which characters, which is what it calls variables, interact, and each act and scene is numbered with a Roman numeral and serves as a catchy name.
Oh, thank you for anyone I didn't know. Do we have time for more questions or?
Yeah, go for it. Sure.
I can imagine everyone's wanting to see, so I'll keep it a small one. What is the future of your company? I guess, like, where do you see yourself in the next 3 to 4 years?
No, it's an easy one then to finish on. I don't know. I think large enterprises will all have some kind of LLM capability in 3 or 4 years, probably sooner, but certainly in 3 or 4 years. These things are like databases in terms of scale and potential revolution in the enterprise. And so the way I see us is every single person on the whole world will be using us in 3 or 4 years. Not really, but
So another rise of a Google version of a bot.
Maybe I shouldn't have said that now. Thank you everyone for coming. If you fancy another drink, there is a pub just downstairs. If you look to your left, it's called the Conductor, which is very nice there. And we will see you all again next month. Thanks. Please don't forget to drop your lanyards of your thank you.
Thanks again, sorry for.
No, it's been really good.
That was very good
Today.
Yeah. Never really registered. I'm also interested about conference. Let's see, I mentioned this at the beginning, but it's best if I talk.
Actually, so I use a system, Cheryl, you know, set me up. I just someone who like used to come here a lot. Just when she's away, I have.
Oh man, can you do a great job? I guess you are in a way of saying.
Yeah. Thanks for listening.
Hi. My name is and I'm just and I was looking for open for roles and into development. I'm from networking field. Yeah, and I'm just I wanted to ask if you guys are hiring at the moment now. Just the or anywhere else, any opportunities you can let me know about.
I think if we have any jobs going, then they will be on our website.
Okay.
You go to the
Just see
section
that, yeah.
for Just See. If we have anything going on,
That's it. That's it over there.
I
What time do you start hiring? Probably when it starts, when the wave starts in the market. I'm pretty new here. I've got no idea anything for any input from you.
Thank you.
These are like this is my second meetup. I've been
so
I've got like 2 years of experience. I'm from Mumbai.
Yeah.
And I've worked in a cloud company and I've worked for Taj. I've worked as a network engineer for that. Okay. I was handling servers for the whole hotel and maintaining. I was working on VLANs. I was working on